Hello everybody and welcome. This is your professor, Dr. Christopher Pliley, talking to you in our first online lecture video post-Hurricane Maria. And what I'm going to do is I'm just going to quite simply talk you through some of the slides that you've already seen posted online for chapter 2.3, and that is the measures of center that we talk about in this class. There are others beyond this, but we will only talk about three different ways to measure the center of a data set, and those are the mean, the median, and the mode. Okay? And for today's lecture, we have one and only one goal in this particular video, and that's by the end of this day, I want to make sure that you're able to find explicitly, given a set of data, the mean, the median, and the mode. So before we talk about what we mean exactly when we say the center of a piece of data, let's think back to an example that we did already. If you remember earlier in the course, we talked about if we thought there was some sort of age discrepancy between the ages of those who happened to win Best Actor and Best Actress awards at the Academy Awards. And if you remember what we did, we looked at all of the ages of the actors and actresses who had won this award, and we sorted them into frequency histograms. Here on the left, I'll change my marker, here on the left we have all of the ages of all of those actresses who won Best Actress, sorted into this histogram, and here on the right we have the actors. And visually, it was quite clear to us that this seemed to imply that the actors tended to be a little bit older than the actresses when they won this award. And so what we were visually doing is we were sort of looking for what we would interpret as sort of the center of this data. And if I look and I say, well, where are most of my ages sort of clustered around? Then for the actresses, I might be looking somewhere around here, somewhere between 25 and 35 is what we sort of thought, and it was clear that the actors were a little bit older, maybe up here in the low 40s or something. Seemed to be that sort of balancing point. The analogy that we used at one point was that if this happened to be something like a scale, where would I balance it at? Where would be that point where it wouldn't tilt off to the left or the right? And it definitely seemed to be a greater age for the actors than it did for the actresses. And visually what we're doing is we're sort of looking for what the center of this data really is. And so how can we calculate this idea? How can we put a measurement on what we mean by the center of this data? Well, in this class we'll talk about three different methods or ways to measure this central tendency, and those three are the mean, the median, and the mode. And the mean is the most popular. I'm sure that you already know how to calculate the mean. By the mean in statistics, we really just mean the average. So if I have a set of quantitative data, in this class our quantitative data is going to be measured with real numbers. So given a set of real numbers, I can always go ahead and find the average of those numbers, and that's what we'll call the mean. If I want to find the exact middle point of my data when that data is ordered, or if there is no middle point, if I want to find a representative of that middle, and by the middle I mean the point where we'll have, approximately 50% of our data below and approximately 50% of our data above. Well, that's a very valid way to describe the middle of a set of data, and that's called the median. And lastly, we'll talk about mode, and this is more an idea of center based around that sort of idea of clustering that we talked about. So it also makes a lot of sense in some cases. In particular, if my data happens to be qualitative, then I can define the center to be sort of just the most commonly occurring point of data. Which point occurred the most in my data? And if my data is indeed qualitative, then that means it's just a labeling. It could be names or majors in college or something like that. If I have qualitative data, then it actually doesn't make any sense at all to calculate the mean or the median, of course. And so when data is qualitative, the only measurement of center that we will use in this class at least is the mode. Okay, so how do we calculate the mean? First we'll spit out the definition of it, which I'm sure you already know. The mean is the most popular and well-known measure of central tendency, and we define the mean of a quantitative. Again, it only makes sense for quantitative data. The mean of a quantitative data set is simply the sum of the data entries divided by the total number of entries. And so let's do an example just to illustrate. Suppose that I have a list of ages of students who took a class of mine last semester. So I had 6 students in this particular class. I can count 1, 2, 3, 4, 5, 6. And the students had ages of 19, 21, 21, 22, 24, and 26. And so if I mean to find the mean of this data set, what do I need to find? I need to find the sum of the data entries divided by the total number of entries. So to do this, all I have to do is simply take my 6 numbers, 19, 24, 21, and so on, and I sum them up. 19 plus 24 plus 21 plus 26 plus 21 plus 22 is equal to 133. Of course, you can do this on your calculator. And then I take these 6 numbers, I sum them up, and I divide, of course, by the number of data points, which is 6. So to find the mean of this data set, I take 133 and I divide by 6, which gives me approximately 22.2. So I would interpret this by saying the mean age of a student in my class last semester was 22.2 years old. Okay, so once we know how to find the mean, we can find other measures of central tendency. In particular, we can find the median of any set of quantitative data. And the median is defined to be that value which lies in the middle of the data when it is indeed put into order. So it is a little bit different to find the median if I have an odd number of data points or an even number of data points. And to illustrate that, let's just take a look at an example. So suppose I had 7 students in my class instead of 6. And let's suppose their ages were listed down here below. You'll see the only difference is I threw in one extra student, 31 years old. And if I wanted to find the median, then all I would need to do is find the middle point of data. So I can take this set of data and I can actually arrange it into order, right? Quantitative data is always ordered. So I put it in order 19, 21, 21, 22, 24, 26, 31. And the median is quite literally just that point which lies in the middle. And here I can see it visually. The middle point, of course, is this 22. I can do it by crossing off values from left to right if I want. Let me change my pen. I cross them off left to right, and the one that's left in the middle is my median, in this case 22. And of course this is easy to do if I have a small set of data by hand. If I have a larger set of data, then it's probably more useful to use some sort of technology. Most softwares like SPSS or Excel will find the median for you very quickly and automatically. But we make sure we know how to find it by hand first. And so in this case I have 7 students in my class, and I say the median age is 22 years. If I have an even number instead of an odd number, let's suppose I was dealing with that 6 original student age list, then notice that what happens is that when I try to find my middle point, I don't quite land on one single value. Both 21 and 22 are sort of in the middle. These are the 2 numbers where I have the same numbers, same amount of data points to the left as I do to the right. So in this case there's actually 2 middle points, both 21 and 22. And this will happen every time I have an even number of values. So if there are in fact an even number of data points, then the median is defined to be just the mean of those 2 numbers. It's the halfway point between 21 and 22. So to find the median here, what do I need to do? I can't just pick a number off my list. I have to take these 2 values, 21, and I'm trying my best to write this neatly, but it's a little bit sloppy for now. I'll get better, I'm sure. I take my 2 numbers, 21 and 22, and I find their mean. And their mean is, of course, just their sum divided by 2. So 21 plus 22 over 2 would give me 43 over 2, which is 21.5. So in this case, my median is 21.5 years. And notice that this is not even one of my data points. There was no student in my class that was 21.5, at least not that I know of. But that doesn't matter. The median does not have to necessarily be one of these values, just like the mean actually. I didn't mention it then, but remember that our mean of this data set was also not one of these numbers. It was 22.2. And the median and the mean are different as well. We're measuring different things. This is the middle point of my numbers. It's not the same as the mean. So lastly, the final way that we'll measure the center of our sets of data is what we call the mode, and the mode is also fairly easy to find. In particular, we can find it by hand when we have a small enough data set. The mode of a data set is just that entry which occurs with the highest frequency. So here I have 6 different values. An extra one here, I'll cross that off. Here I have my original listing of 6 students in my class and their ages, and the mode is just that value which occurs the most. So it's very easy to see. I don't even need to look at the ordered list on the right. I can just look here and say, well, what number appears the most? It's 21. 21 occurs twice, and no other number occurs twice. And when I put it in order, I can see it as well. Right here, 21 appears twice. So the mode of this set of data is just 21 years, because it occurs twice, and every other point of data occurs only once. A quick note, what if no number appeared twice? What if this student here, for instance, was not 21? What if they just weren't there, or what if they were 18 or something like that? Then I would have no number that appeared twice. If no data entry is repeated, then we just simply say there is no mode. There can also be more than one mode. Let's suppose that I had 2 students who were 21, like we originally did, and I also had 2 students who were 26, for example. Then in this case I would have 2 students that were 26, 2 that were 21, and both of these values, 21 and 26, would have occurred with the same frequency. They would have both occurred twice. In this case I would have said I just have 2 modes. My 2 modes are both 21 and 26. So a data can have no mode, one mode, or more.